Oh, thank you for that. Thank you for making sure the recording is in place. Okay.
Sure. Hey, everyone. My name is Charlie. I'm the co-founder and the principal of XCamp. Today, we would like to have a trial class, which means you guys spend the next 1.5 hours with XCamp to see if you like this coding class or not. We call it trial. Before class, I want to share some of our thinking, especially at the AI era. So everyone knows AI is coming. AI is changing our life. It's not in the future, it's now. Some of you might have been using ChatGPT to help you, or you might use other like image robots. So that's kind of a time machines can really help us. So not only help us do labor work, but also help us maybe do some mental work, intelligent work. So we call it AI, artificial intelligence. The key question is, if AI keep advancing, how we, especially you young next generation, to adjust to this new AI era. So today here, I want to spend next 5 to 10 minutes to share some idea of mine and XCamp. First, AI will replace some jobs. Maybe even in the long term, AI will replace a lot of jobs. In some time, AI even might replace some coding jobs. Now, I think it is doing now. We got a report from Google recently. I worked in Google for 11 years, so I just left Google working on XCamp now full time to serve your guys. Google just reported, currently about more than 25% of the coding work is doing by AI now. It's also keep rising. So next question is, do we still need to learn coding? So what's the purpose of learning coding? Or maybe other jobs, like account content, even some lawyers' job, especially, organize the documents, right? Came out a report. This might be replaced or can be done by robots, by ChatGPT, or by other AI tools. So how we could handle this? Yeah, this is kind of first topic I want to bring up here, bring to all of you. Also, you could include your parents in this real AI era. So what can we face this kind of situation? From us, the second topic is we believe even the tools, the AI tools keep evolving, but the thinking, the critical thinking, the analytical thinking, the computing thinking, especially problem solving, problem analysis, is still the key, for us to move forward. That's also the goal of XCamp's class. We're not only teaching how to code, but more importantly, we will teach you how to think in the computing way. Also more how to think in analytical way, how to you analyze problems and how to solve problems, how to initiate the solution. Also, because you have these coding skills, you have this capability to using tools, you could understand how AI works. This can facilitate your problem solving skills. I think that's the key part or why XCamp, teaching kids not only coding, but more importantly, we will teach you algorithms and the data structure. That's the key training for your mind, to learn this computing thinking process, problem solving process. Yeah, that's the second part I want to share with you as XCamp. We're not only coding school, we are kind of a brain training school to train you to solve problems. Today, definitely in the next 1.5 hours, our teacher will show you how to do some coding problem, how to use code to generate, some figures, how to draw stuff just with a couple lines of code. That will be fun, yeah. Finally, I like to say for all of you, even more importantly, to be an independent thinker. The reason is the AI is growing so fast. I think no one can predict what will happen in 20 years, 30 years, or 50 years. Someone may think, like the artificial general AI is coming, especially artificial super AI will coming. So if it come, maybe our whole life will be changed. The only thing you can handle the situation is you are an independent thinker. You have your own opinion, you have your own analysis skills. You can hands-on to implement your thinking, implement your goals. That's kind of another skill. We use train coding, use this class as a tool to train you to think independently. In other words, if you are independent thinker, you will be proactive. You will be self-motivated. We believe that's the only way for us to adjust the new AI era. Because no one can tell you what's wrong, what's right in the next 10, 20, 30 years. That's also, in XCamp, we motivate the students to solve problems even not taught in class. So we also encourage students to work together so they can encourage together. Also, they can encourage them the teamwork, also the leadership. So that's kind of 3 points I want to share with you before the class starts, because I believe this is so important. First, we are in the AI era, it's coming. So we need to face that. Yeah, secondly, we need to focus on the capabilities on computing, thinking, problem solving. Finally, hope all of you can be an independent thinker to think your future, to adapt to this keep changing world. Today, we are very happy to have Brandon here to be our teacher. He's one of our kind of first group of teachers. He has spent, I think, almost 5 years with XCamp. He's also one of the most student-loved teacher here. Feel free, to learn. Also, feel free to answer questions by raising hands. We unmute all of you to make this class more efficient. So if you have any questions, please raise your hands. So we will unmute you, and also you can type your questions in the chat too. Okay, great.
All right. So that's our message from Charlie. So just wanted to sort of introduce XCamp and talk a little bit about sort of a very, very important question. Why should you learn to code? Why is that important? If AI and other technologies can write code for us, why should we learn to code? So we are here to learn to code today. So yeah, we're going to be talking about some of these things, and hopefully by the end of the class, you'll see some of the advantages of the kind of thinking that we do when we're writing our code. And this idea of computational thinking or learning how to interact with technology is super, super valuable and important, especially now that technology is everywhere in our lives, which we will talk about today. So we will get started with our class. One thing I wanted to say, well, actually 2 things I want to say before we get started with our class today is, yes, Charlie is right. If you have questions along the way, you will be able to raise your hand in Zoom, and I will call on you. I'll mention a little other detail about that very shortly. If there are parents who have questions specifically about XCamp and the structure and sign up and all those other details, that portion will be left to the end of the class. So we have a two-hour window. We'll have our class for an hour and a half, and the last half hour will be left over for some more information about sign up and XCamp and all those other details. For those related questions, please save those for the end. And this first portion will just be specifically for the class. Okay, so like Charlie mentioned, my name is Teacher Brendan. I have been teaching at XCamp for many years now, before even COVID. I've taught pretty much all of our classes that we've had, from the beginner entry level class, which is very, very similar to what you guys are going to learn today, all the way up to our higher level classes that are more focused towards the direction of competitive programming, if anyone knows about that or is interested in that. And yeah, welcome. I hope you enjoy the class today, and we're going to show you a little bit about what XCamp class is like and give you yeah, a little sample. So the first thing I want to say is a couple of rules. So normally in our XCamp class, when we have this online class, we need to make sure we have some rules. And the first thing is that we usually have our camera on. Now, this is a trial class and there are lots of students. And although I have my Zoom window open and I'm trying to see as many students as I can, I definitely can't see everyone. And of course, because it's the first trial class, you may not have your camera set up or you may not be comfortable turning on your camera, and that is totally okay. So if you would like to turn on your camera and participate in the class in that way, you are more than welcome to. But if you don't want to, I totally understand. You don't have to have your camera on today. But in a normal XCamp class, you would have your camera on so that I can see you, you can see me, and we can interact with each other in that way. The second point is about respectful communication. So the way that this online classroom works is that it's it's not just going to be me talking the whole time, especially in the XCamp classes. It's a lot of I explain something, we ask some questions, and we have some discussion, and there's a lot of students talking and participating during the class. However, in a large class like we have today, it is a little bit challenging to hear from everyone. So the way that it works is that you keep yourself on mute, and if you would like to participate in the class and like to add your comment or your question, I would like you to use the raise your hand sign in Zoom in order to show that you would like to be called on. So, for example, I can see Celine has her hand up. She has her hand up in Zoom. Awesome job. You're showing me that you know how to do that. And feel free to test that out right now and make sure you know how to raise your hand and then also lower it after when you're done, after I call upon you. So that's our protocol of how um, how we communicate in this class. Okay. And in terms of annotating on the screen and other things like that, you will not need to do that. The chat as well. It's probably going to be too many chats for me to keep up. And normally we don't use the chat for communication. We just sort of raise our hand and then the teacher will call on us to speak up. Okay. Now the third part is about class participation. So like I mentioned, typically in the XCamp class, we're all participating. I'm talking, the students are talking. When we have little practice exercises, all the students are going to do the practice exercise, and whether they are able to complete it successfully or not, they will, submit something and talk about their code and all that kind of stuff. Now, like I said today, because we have a very large class and it's just a trial class, you don't have that obligation to participate in the class. So if you would like to participate, great. And that's going to be nice for me to sort of get to know you a little bit better. But if not, feel free. It's totally okay to just sit back and watch the class. That's okay as well for today. And then the other thing is about your Zoom name. So if you want to participate in the class, just know that since I don't know you yet, the way that I will call upon you is on your name that's listed in your Zoom. So just make sure that if you want to participate in the class, to make sure that the name that you have listed in Zoom matches what you would like to call me. Or even some students that what they do is they just put it in parentheses, and that way I know what you would like to be called. If not, if you have your hand up, I'm just going to call you based on the name that I see on your Zoom account. So if you would like to take this moment to change your name in Zoom, please feel free to do that. Okay. So those are our class rules. And actually, but one more thing is before we get started with our content for today, I want to tell you what I'm showing you right now because you guys are new students. You're probably wondering what is this website that I'm showing you? Where are these slides? So what you're looking at right now is what we like to call our learning site, which is learn.xcamp.org. And our learning site is this website where our students can have an account and they log into, and they can see all the information about their class. So right now, I'm showing you the information for our class specifically. All we have are just this one little slide deck, which are the slides that I'm going to show you today. But normally what you would have is you'd have all these little sections for each of the week's content for the different 10 weeks of the class. And it would include slides and homework and all that other kind of stuff. So normally we'd complete our homework and look at the slides, everything within the learning website. So this is really our one stop for everything that we need for our XCamp content. As well, we have a coding editor, which I'll get to in a moment. But really, this is everything that you need. So that's what I'm showing you today, which is our learning site. Okay, so what are we going to learn today? So today, what we're going to learn is we're going to learn introduction to Python. So the very, very basic concepts of Python programming. We're going to talk about what is programming, what can we use it for, all that kind of stuff. And then also we're going to talk a little bit about at the end algorithms and data structures, just a little introduction to kind of give you an idea of some of the stuff that we do in our XCamp classes. And then the main chunk of what we're going to do today is we're going to play around with a Python library called Python Turtle. So I will explain all that stuff. There is no expectation that you know anything about coding at all before this class. I will make sure that I introduce all of that stuff to you today. So if you know a little bit about coding, great, awesome. You'll have a little bit of a jump start. But if you don't, that's totally okay. I'm going to go nice and slow and make sure that we have some time to learn all of the basics along the way. Okay, so the first thing that I want to talk about before we start writing our first code is what is programming or coding, right? So essentially all it is this idea of we give some instructions to our computer and our computer completes them step by step. Now, if you haven't seen any code before or you haven't written any code, you might be asking, well, what are those steps or how is it completing these actions and all that kind of stuff. And so we're gonna see that very shortly. But that's essentially all it is we're going to write some instructions. You can kind of almost think about it as like a recipe when you're cooking. You have some instructions of what you need to do and when you put certain things together. And then you are the human program. You're the one who follow that and put everything together. So you can think about it in terms of this writing code is this idea of putting down these instructions, which the computer will follow and execute for us. Okay, so in the next one, I have this little, here, let me make this a little bit bigger so we can see better here. Okay. All right, hopefully this is a little bit easier for us to see. Maybe we can have some little interaction here. So this slide is saying, hey, what are the things that we can do with coding? And there's some photos here that maybe give you a couple ideas of some of the things that we can do with coding. So does anyone want to raise their hand and either help explain one of the photos on the screen and say, this is what it has to do with writing code? Or you can also come up with your own example of how coding exists in some other aspect of our lives. Okay? All right, I think I see William. William, you have your hand up. Would you like to explain one of the examples or come up with one of your own?
Yeah. Um, the first one is chess. I think there's something like chess websites you can actually use that's not like in real life on your computer.
Yeah. Yeah, and what happens when I guess I'll ask a question. So, is anyone ever anyone have like an account on chess.com or play online chess with their buddies? A lot of our XCamp students actually do. I noticed that when I went to the camp, when we had break, a lot of the students were, I thought they were playing games with each other. Actually, they were playing against each other chess on chess.com. It's pretty cool. And also not just playing chess against your friends, but you can also
Worldwide.
chess online against, like, for example, like a AI player, like a robot player, right? So has anyone ever been playing chess online and they're thinking, oh, how does it know when I'm playing against this like AI player, how does it know where to move? Like, how does it know if I select this easy mode or hard mode, how does it know where it should put certain pieces and sort of set me up to make this an easy opponent or a hard opponent, right? There's logic involved. There's computing involved in deciding how those kinds of things happen, right? And so, okay, number one is the people who create the website and maintain it and all that kind of stuff. That's already one part of writing the code. But another aspect is the decisions that are being made when the game is being played, and so much more that's involved with playing chess. Yeah, so that's a really cool example. I like that one because we often have students who are interested in playing chess and play chess online. Okay. All right, let's see who's next to explain another example or bring up their own. Celine, would you like to explain another example?
Never mind.
Never mind. Come on, come on. Can you pick one of these ones? No? Okay, okay. I'll go to the next person then. I'll go to the next person. Let's go to Anthony. Anthony, help me out.
So I'm thinking that we could use coding to create games like Minecraft, Survivor.io,
Yeah,
something
what's
like
this
that.
game here in the bottom right-hand corner?
It's Minecraft. I heard there's a movie that was just released about it.
Yeah. So, if you like to play games or know a little bit about gaming and all that kind of stuff, gaming, these computer games, they're built with code, right? There are teams of engineers who write code in order to
Yeah.
make games. And so this whole world of gaming involves, people who sit down and they write code and they sort of design the instructions for what should happen when you move left or move right or click on the mouse and all that kind of stuff. So gaming is very intertwined with the world of coding. Of course, there's some art involved and other stuff like that, but the creation of these games involves so much actual coding. And even there are some games where you yourself create some worlds where you write some code in order to create that. So even as well, there's opportunities if you learn how to code to do stuff like that. So that's pretty cool. All right, so we have the chess one and we have the gaming one. Do we have some other examples? Matthew? Matthew Yang, can you help me out?
So just building off of what he just said, in Minecraft, so like when you're making redstone contraptions,
Mhm.
um, there's actually lots of coding going on, and you're physically like sort of making the code by say you have a redstone torch and there's like a trail, and then there's a trail of like redstone in front of it, and then and then it keeps on sending out a signal until the trail before it gets light lit up.
Yeah, that's a really great example. Thank you. Cool. Let's go to another person. Let's go to Alex. Alex, you want to add something else?
So in the one to the left of the Minecraft one, those are the robots, and then so you can move them with a joystick. For example, like if you like move the circle around it, the wheels will move and change direction. And if you press a certain button, something like for example, a cannon will launch or something.
Yeah, that's exactly right. Maybe we're a little bit young for a lot of students to have participated in robotics or sort of be involved in that. Maybe some of you have, I'm not quite sure. But yes, robotics definitely involves a lot of coding. So in terms of how are these, how, you know, when we say the joystick needs to move upwards, what does that mean? How does the robot react in that way, right? We need to write some code in order to help that. And actually, I really like this example because today we're going to be writing some Python code, and a lot of times things in robotics are often written in Python code. So yeah, I think that's a really great example for us today. Okay, cool. Any other examples? Like maybe the one in the top right or the one in the bottom left? Brian, do you want to help me out?
In the top right one, there's the apps, because in apps you have to do like a lot of coding, because then like in Safari there's like a bunch of websites, and there's also Google's, and there's a lot of coding just to get there.
Yeah, that's absolutely right. So all these applications within our phones and tablets and everything, even we have applications within our computer and stuff like that. They are all built with code. Okay, so we'll talk about that a little bit when we get to the programming languages section. But yes, there are often engineers who sort of maintain these applications and sort of decide what happens when you click on this button in the app. How does it react, or how do we save your information and make sure that when you come back to the app, that information is there? All that kind of stuff comes from engineers writing code. And so that's a really great example. And how about, I like this one in the bottom left because it really is very similar to some of the stuff that we get to do in our entry-level Python class for XCamp. Does anyone want to explain this one in the bottom left-hand corner? Yeah, Jaden?
So I think so for some animations, you can code them to like move somewhere or do a certain action by coding them to change through, usually it's changing through pictures, I think.
That's right. Yeah. So all animations are these pictures that move, and they move at a speed that's quick enough for us to sort of trick our brain into thinking that they are alive, that they're actually moving. But essentially, all they are is a bunch of photos back to back that are being cycled through very quickly. And because those are computer graphics, those images, that involves code. And so you know, all these examples really from this sort of animation world involve actually a good chunk of coding, as well a lot of art too, I will say, but definitely lots and lots of coding as well. Okay, so I think that you know we've covered these examples, and there's this drone here as well that we can see that involves coding too, deciding how that moves. But from all these examples, hopefully what you take away from this is that there are so many places in our everyday lives that involve code. And because it's in so many different places, we often don't even think about it, that in order for this to work, someone had to write some code in order for this to happen. And if there are any problems, if there's any problems with our game or apps or stuff like that, we need engineers, we need people who know how to write code to go and fix those things and also create new features, new levels for our game, new features for applications, and all that kind of stuff. So there are always lots of opportunities for people who understand how to interact with technology, and also who know how to write code or interact with code. All right, so this next one, I have some programming languages in here, and there are lots of them. So the question is, if there are lots of ways in which we can write our code, it's kind of thinking about there's lots of languages when we speak, like English or Spanish or French or you know all those things. Why do we have so many of them, and do they have any purposes? I'm just curious, does anyone have any like experience or know anything about any of these languages here on the screen that they would like to share their experience? Alan, would you like to speak up?
So in the past, I have worked on games with coding languages such as Lua, JavaScript, and C# on Unity. So yeah.
Awesome. Yeah. 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 So that's really great that you have a nice little head start today. JavaScript is this one here in the middle. I don't have a photo of Lua. Lua is a nice one for gaming and some other scripting and things like that. C# I don't have here. I have C++ on the screen, but yeah, those are some nice examples. How about Jaden? Do you have some examples you want to share?
Yes, like at my school, like there's like a Python class, and I'm like in the class.
Very nice. Okay. And anything in particular you guys are building or creating in that class with Python?
Yeah, like some games.
Cool. Some games. Awesome. Yeah. Um, yeah, there's a lot of cool things that you can do with Python and creating games. And there's like something in XCamp that we use in our 102 level class called Pygame, where we make a little game with Python. Let's do one more example. Celine, do you wanna give an example? You have your hand up?
My mom uses C++.
C++. C++ is a really cool language. So C++ is not an easy language to learn. It's definitely a lot more challenging. And actually, one of the cool things about C++ is that it's a very fast and efficient language. And so when speed is important for our application, oftentimes we use languages like C++ or Java or C or other things like that that are on the faster side. Now, in XCamp, we get to learn C++ in our higher level classes because of its speed and performance advantages. It's beneficial when we're doing stuff like competitive programming. So yeah, if you stay in XCamp long enough, you get to learn some C++, which I think is really fun and cool. Okay. Okay, and as well, there's some lesser known ones, but interesting ones like Lisp. Here in the middle, these ones are languages for the web, JavaScript and HTML and CSS. And then we have some newer programming languages like Golang, which are kind of fun and exciting and yeah, something for us. If we continue down the route of coding, we'll eventually run into some stuff like that. Okay, so the question is, well, if we have so many different programming languages, why learn Python? And so the reason that we're going to be learning Python, and we learn Python as our first language in XCamp, is because it's a very beginner-friendly language, okay? And the reason why it's so beginner-friendly is because number one, it looks a lot more similar to writing just like English sentences than some of the other programming languages. In some of the other programming languages, um, we often need to write like a bunch of semicolons and squiggly brackets and other things like that to show specific things. In Python, that's not necessary. Okay, so it looks a lot more like English, and so it is a little bit more natural for us to read and to understand. And then as well, the other advantage of learning Python is that it has a lot of application in different things later on. For example, if you're interested in artificial intelligence or robotics or data analysis or other things like that, those are all things that Python is a language that has a lot of advantages for completing those tasks. And so it's a really great entry point for us if we eventually want to get into those things. Okay. All right. So we are going to write our very first line of code. Okay. So if you had the time and you had the ability to do the setup, you have a code editor. So this is just an application in which we can write and run some code. This one is called Thonny. Okay. So if you have this and you have this all set up, you'll have something like this. Mine's I changed it to the dark mode, so maybe it's a little bit easier for you guys to see. But this is where we're going to write our code. So I'll show you from here. I'm going to copy the one on the screen and I'm going to write print hello world. Okay. And the way in which in Thonny, run my program is I hit this play button, the screen play button in the top, okay? And I get this message down here at the bottom. Okay, now the question is, if you did not set up this Thonny editor before the class, that is totally okay. You have other options, okay? So there's some online editors that you can go to in order to write some code, like Replit or Python Sandbox. I actually really like this one here, which is this Trinket.io. It's going to have this turtle window that we can use for some of the stuff in the class today. So what I'm going to do is I'm going to show you that same thing here. Actually, let me remove that. Okay, let's go like this and do that same command. Hello world. And what I'll do is here I have a play button. I'll hit the play button and I'll get that output here on the side. So in the Zoom chat, what I'm going to do is I'm going to put a link to this website here. So if you don't have your editor set up, you can click on that one and give it a try. As well, if you want to, you can always just sit back and watch me write the code, and you can give it a try after class as well. So during the class, because I have so many students today, I won't be able to help you with your setup if your Thonny editor is not quite working, or other stuff like that. So yeah, do the very best you can if your setup is not correct. And like I said, if anything is not working, you could always make sure that you set it up after the class and give those exercises a try. Okay. All right. So when we clicked the play button, what happened? So I'm going to go back to my Thonny editor. And what happened was I see this text that comes from this line here, this print appears down at the bottom in this section here down at the bottom. So that's what I'm seeing what's happening. Okay, and so essentially what I'm doing is I'm telling my Python program to send some text, some text information to the screen, to this console down below. And so that's what's going on over here. Okay. All right. Now that we've written our very first line of code, I want to introduce you to something called a library, okay? So in our case, because we are new to programming, there is a lot of stuff that we have to learn at the beginning to start writing code, right? Especially things where we want to do some drawing or games or other stuff like that. And it could take us quite a long time. So one of the cool things about Python is that we can actually use some code that other people have written, and we can use that at our advantage in order to gain access to some tools, okay? So for example, if I wanted to do some drawing, how could I really do that with this window down here below, with this console window? This doesn't have, by default, any graphics that can just appear in this. Sure, I could maybe create like a smiley face or something like that, with, put some characters here in order to do that. I could print out some characters for that kind of thing. But in terms of creating some graphics or some like circles or shapes or other stuff like that, I couldn't do that with this print command. So we are going to use something called a library, which I said is our way in which we can import or we can collect in some code that was written by someone else, and we can gain access to those tools. So we are going to take in this, we're going to collect this library. It's called Python Turtle, and it's a library that will allow us access to a new window, okay? So instead of this one, a new window is going to pop up, and we're going to have a bunch of commands. We're going to be able to sort of move around the screen and be able to do some drawings. So in order to do that, in order to gain access to that library, we need to import it. So the first thing that we'll do is we will write this import turtle. Okay. All right. Now that I've imported or I've collected the code for this library, I'm going to show you a command in which we can use in order to create a turtle. So you might be asking right now, Teacher Brendan, what is Python turtle? What does it have to do with turtles? What do turtles have to do with drawing? It's the name of the library. And the reason why you will see it's called Python turtle is that the idea is that you have this little turtle that can move around the screen, and wherever the turtle moves, it's going to draw below it. Well, actually exactly where it is, okay? So the first things first, we can create a turtle. I'll just name my turtle Ted. You can name your turtle whatever you like, but I will create it by using this library's name. So this is the exact same name as my library. I'll use a dot after, and then this is a command that comes from that library, which helps us to create a turtle. Okay, so I'll hit the run button. And what happens? What happens is I get this graphics window, okay? This Python turtle graphics window. And I have this little arrow that's right in the middle of the screen. And this is my turtle. This is my turtle, okay? And like I said, what's gonna happen is when we tell our turtle to move around the screen, it's going to sort of draw exactly where it goes. So we'll do commands like telling it to move forwards or turn or other things like that. And wherever it moves, it's going to draw a line below it. Okay, so that's what happens is we get this whole new graphics window, which is going to do the drawings for us. Okay. All right. So, like I said, the window that we saw, all it had was a little triangle. If we want to, we can change the shape. So we also have this shape command that we can use here. Here, and we can change the shape of it. Okay, so I'll say my name of my turtle, and so I can change the shape specifically of that turtle, and I'll do dot shape, and then inside I'll put the shape that I want it to turn into. So here, if I want to turn it into a turtle shape, I'll do that, and I can run my code, and there's my turtle that appears in the middle. Okay, so if we don't do that, if I don't run that, by default, Python turtle will just give you this little triangle that appears in the middle, which will be used for my drawing. If I want to, I can change it. There's some other options as well, to a circle, to a triangle, arrow, other things like that. Okay, so that's it. If you would like to do that, and if you're curious about why this is called Python turtle, that's the idea. The turtle does the drawing for us. Okay. Okay. So how do we move the turtle? Like I said, we have some commands that are going to help us to move the turtle around the screen. And the first command I want to show you is this forward command. So I'll say the name of my turtle like this. Let me go back to my turtle. I'll say the name of my turtle. I'll use the dot, and then I can tell it to move forward. And then I'm going to put a number inside of it. We'll talk about what this number is. I'll ask you guys to help me out and explain what this is. And I will hit the play button. What do we notice? Well, what we notice is that if we watch it again, what happens is that my arrow moves across the screen to the right, and it ends up on the side here, and it draws this line going from the middle out to the right side. Okay, so this is probably the moment. Actually, let me leave this open so we can talk about this, and let's look at the left side. So there's a couple questions that we probably have at this moment. You're probably saying to me, Teacher Brendan, what is 100? What does 100 mean? How do I know if 100 is a small amount or a large amount? What kind of scale are we talking about? And the other thing you're probably asking me is, Teacher Brendan, if I told my turtle to go forward, how come it moves to the right of the screen? How come it didn't move in the upwards direction or some other direction? How do I know that forward means going to the right? Okay, so these are interesting questions that we should be asking ourselves. I'm just curious, does anyone either know the answer or have a guess for one of those two questions that they think they could help us out with. Okay, I see some students are really, really eager. Matthew, help me out with one of those.
So just saying, it moves forward because it's like because it's so if you're the turtle and you're pointed in one direction and you move forward in that direction, and then so it is, and then it is moving towards the right because it's pointed towards the right. And also I want to share something.
Sure, go ahead.
It says that host disabled participant screen sharing.
Oh, you want to share your screen? Okay, just tell me if you want me to change the code.
Yeah,
I can.
so oh yeah, so I'm just gonna put this on annotations.
Do you want to tell me first?
Yeah, it's a script for code. And
Oh,
then
it's okay.
it's called the
we
Fibonacci
can
sequence, and I think it's gonna be pretty cool if you actually played it in front of everybody.
we can maybe save that for a little bit later if that's okay.
Basically,
we-
you gotta keep on repeating this, something like that.
We probably for now just want to stay on this example. Okay, so I'm gonna clean this up. So sorry about that. Well, let's start slow and make sure that we're all on the same page and keep this simple. So so you are right. What's the reason why it moves out to the right side? Because if we look at the direction that our turtle's facing, so let me take away this piece of code here, and I run my code here. My turtle is facing towards the right. And so when I say go forward, that's the reason why it moves out to the right. Now, if I wanted to move in another direction, what I could do is I can change the direction of my turtle and then say move forward. So I can move it left or right. I'll show you those commands on how to turn it. But that, if you're curious, that's the reason why it moves out to the right side instead of some other direction. And how about for that second piece, for 100? Who thinks that they have an idea of what 100 means? Michael? Can you help out?
So 100 is like, so whichever direction the turtle is pointing, the turtle moves like, I don't know, 100 pixels or 100 units, whatever the unit is, to that direction.
Which one do you think it is? What do you think the units are if you had to guess?
I don't know, like a millimeter.
Millimeter? Yeah, these are very good guesses. You kind of what we could do is we can just kind of look at it and go, all right, let's look at our photo here and see what's going on, right? Let's see how much this looks like right here. Okay. But we can actually answer this question here, which is oftentimes when we're thinking about
Pixel.
measurements within our screen, we're often talking about pixels. Okay, so in this case, when we say, hey, move my turtle Ted forward 100, it's saying move my turtle Ted forward 100 pixels. Okay, and what these pixels are these tiny, tiny, tiny little squares that represent our screen. And because they are so small, we don't see these squares. And they are what helps us to see, for example, this text as being smooth or these photos as being smooth. And each of these little pixels has some sort of color or some light that it emits to show us how it should appear on the screen. And so when we have all these pixels close to each other, really, really small, you can't even really see. I'm not sure if you guys have ever maybe you had a screenshot of a photo and you blew it up really close and you can see all these tiny little squares. And that's really showing you in these digital images or these screens that everything is really made up of this unit, which is the pixel. Okay. If you're curious about the size, pixel is about 1/196th of an inch. So it's quite small. And like I said, it gives us this illusion when we have these tiny, tiny little pixels close to each other that we have this smooth image, even though if we were to zoom in really close to it, we would see really something like this photo, which is all these little these little tiny little squares. Okay. All right, that's cool. So we can actually we skipped one command here, which was the backward one. Let's make sure we do that one first. So not only can we move our turtle forward, but we can move our turtle backward with this backward command here, backward. Okay. And when I run my code, I can see my turtle moves in the backwards direction. Okay. I can move forward and I can move backwards. And we can do a lot more than that. So let's show you a couple more things before we get on to some fun stuff here, which is we can change the pen color. So for example, if I wanted to change the pen color to red, I would do something like this. So like this. Okay. Ted.pen color and red. And I put this before. Okay. And I run my code, and you can see the pen color of my turtle is now red. Okay. Now, there are lots of colors that we can use. And so the question is, Teacher Brendan, can we just put in any color that we want to? And the answer is no, you can't just put in any color that you want to. So how do the colors work? In Python Turtle, we have something called a named color, okay? A named color is like, for example, red or yellow or orange, or all these colors that when I put this inside of the parentheses, Python Turtle, the library, will be able to understand that and change the color that's represented for your screen, okay? But maybe it doesn't match exactly the color that you were looking for. And so if you're curious about this, I have some colors. There are some named colors. So for example, you can see like all these colors have Python Turtle names. So if I took this and copied this name forest green and go back to my code and put this here and run my code, here, I can see I get that forest green color. So there are some name colors that I can use like this. Okay. There's other ways as well in Python Turtle that we can change the color to get any color that we want, like using this hex code or using these RGB values. For the sake of time, we're not going to learn how to do these ones. We don't need to know how to use every color today, but just know that the main colors like red, green, blue, orange, black, white, all that kind of stuff is, matches up with these name colors. And yeah, you can try it out and see if that matches. If not, you can go to this site and look at some of the name colors to find the color that you are looking for. Okay. Andrew, can you please stop annotating on the screen? Okay, let me clear all the drawings. And let's see. My TA, can you help me to disable Arthur? I'm gonna call on you quickly. Do you have a question? Okay, go ahead and ask your question.
So I just don't really know like how to like run it because I typed in like everything, but I don't know how to like because when I press enter it just gets a new line. I don't really know how to
play the code. Are you
Yeah.
using the Thonny editor or are you using
Thonny? I'm using the Thonny.
So if you're using the Thonny editor, do you see this green play button at the top?
Oh yeah.
Press that one, okay?
Okay. Oh, thank you.
Okay. Okay, cool. All right, we can continue on. So like I mentioned, we have these named colors that we can use and put them in. And there's some other ways as well in which we can add some colors if we really want to. Okay, let's go even further. How can we make our turtle turn? So like I mentioned, by default, our turtle is facing towards the right, and we can move forward and we can move backwards. But how can we go in other directions and point in other directions of our screen? And the way we can do that is by using these right and left commands, okay? So when I use this right command like this, so let's just copy it here. And let's go back to my Thonny here and turn. Okay, let's get rid of the backwards command. Let's just see how it looks like when we turn. I run my code, and do you guys see how my turtle is facing down? Okay, so why is my turtle facing down? If we think about it, starting facing towards the right, and then I say turn right, it's going to sort of move in that downwards direction. Versus if I do this left command like this, and I run my code, it's facing in the upwards direction. Okay. All right. You probably have more questions. You're saying, okay, what does this 90 mean? Okay. What does this 90 mean? What does it mean turn 90 pixels? Does it mean something else? Mason, do you want to help me out? What does that 90 mean?
90 degrees.
90 degrees, yes, this is exactly right. So in Python Turtle, when we're sort of moving around and sort of changing our angles and stuff like that, we need to know a little bit about geometry, not too much, but we need to know at least a little bit about degrees. And so a 90 degree, so this photo here is going to help us out a little bit. A 90-degree turn in our geometry is if we're going in the flat direction, it's moving in the vertical direction. Okay, so here is our wheel to show you the different angle of degrees. And so, for example, sort of that halfway point to turning is 45 degrees. Going completely in the opposite direction, it's going 180 degrees. And sort of moving in the other direction here, going sort of almost one rotation down is 270. And we have 360 in order to get all the way back to 0 again, okay? So you can think about it in this sort of degrees in terms of turning. And actually, we can use any of those. So let's see, for example, if we turn, 315 degrees, how does that look like? So let's go back to our Thonny. And let's turn it back. Let's change it to 315 or something like that. And we'll run our code. This. And do you see how it's sort of facing in that same direction here as it shows on the wheel? Okay, so that's how we can change the direction of our turtle, so we can point it in different directions in order to sort of like change up how we want to do our drawing. So now that I've taught you a couple commands, I taught you how to move forward, I taught you how to move backwards, I taught you how to change the angle, I taught you how to change the color. I think that we have a good amount of tools to do a couple exercises, okay? So here it's your turn. We're gonna give this one a try, and using those commands that we learned, can you recreate this drawing here? Can you draw this square? Okay, so what this says is be as accurate as you possibly can. So even look at the direction of the turtle, and even if you can match that up, try and do that, okay? So see if you can take a moment to try and recreate this by using your forwards, backwards, and turning type commands in order to create this. And all this at this moment, while we're waiting for our students to write the code, let's see if I can answer a couple questions for you guys, if you guys still have some questions. Anthony, do you have a question? No, just forgot to lower your hand. Everyone who has their hand up, do you have a question, or you forgot to lower your hand? Some people have a question. Michael, do you have a question?
Yeah, This is pretty similar to logo, right? Terrapin logo.
It's similar to what?
Logo, Terrapin logo.
Terrapin logo? What's Terrapin logo?
It's a
Oh, so
the
it's this
turtle
coding language that like
turtle thing.
basically it's like it also has a turtle. Yeah, it's basically the same thing, but it's a little more like typing.
Oh, cool. I suppose so.
Okay. Wait, if we're done, how do we show you?
Oh, I'll write the code and you can compare your code against mine.
Okay.
Okay, so I'll give you like another minute or so. See if you can figure that piece out using those commands. Meantime, we'll get my editor open. Ray asked an interesting question. Can you slow the pen down? Yes, we actually, I don't think it's on our slides today, but if you're curious, you can do speed command. So you want to make your drawing really fast, you can put 0, or you can try different numbers to experiment with the speed. But like I said, not part of our learning today, just something for you to try out if you're curious about it. Okay. All right, cool. Let's do this together. So it looks like the line here is in the black color, so I'm not going to use this pen color command. The default gives me this black pen anyway, so that makes my life easy. And I think the way in which I'm going to do this is I'm going to move forward. And then after I move forward, let's say it's like maybe like 100 or something like that. What I'll do a right turn to point me in the downwards direction. So I'll go right 90 degrees. And that should sort of put me on the side and then start me pointing in that downwards direction. So then what I can do is I can do that same thing again, like this, where I move forward, right? I'm now pointing in the downwards direction. I can move forward again and do another turn, right? And I suppose what I'm doing is I'm just kind of just doing that same thing over again, right? So forward, turn, forward, turn, forward, turn, forward, turn. And when I run my code, it will take me back to the beginning again and even point me in the same direction as my picture shows, okay? So how do I draw a box? Well, I need to, well, specifically a square. I have these 4 forward commands, right? 1, 2, 3, 4. Those represent all the sides of my square. And also I have these 1, 2, 3, 4 turns that happen, which represent the different corners of my box that help me put myself in the right direction so that my code can work. Okay, so that's how we can do that one. Let's do one more exercise. See if we can. This one's a little bit trickier. So see if you can give this one a try. There's definitely a couple different ways in which you can do this one. I guess same as the other one. There's a couple ways that you can do this. And I see that some students are sending me your code. So feel free, if you want to, you can send me a screenshot of your code. Or you can copy and paste your code if you like to. And we'll give this exercise a couple of minutes for you guys to do. Oh, and some students are asking me questions about how to do specific things that we haven't learned. I'll do my best to respond directly to you in the chat, give you some hints in case you're curious. Yeah, let me see if I can answer a few more questions, and then I'll show how we can do this one. Okay, I'll try to answer as many questions as I have. You have some really good questions. Some of you are curious about like, how do I change the pen size, or how do I put the pen up and pen down and stuff like that. And I hope you guys can be patient with me, and I hope you guys understand that we only have an hour and a half for our class today. So there's a lot of stuff that I don't have the time to show you, although I would really like to. So I apologize. I would love to show you a lot of those commands and give you examples and all that kind of stuff. We definitely, all those commands and questions that you guys have are things that we learn in our 100 level Python course. So if you are curious about how to do that and want to, learn that stuff, I guess that gives you a reason why you might want to sign up. But for the sake of our time today, it's not something that I have time to explain all those different things. But if you're curious, and you don't have the patience to wait, feel free to go to Google and type in like change pen size Python turtle, and it will show you the command. But in terms of me showing you that and giving examples, all that kind of stuff, you have to be a little bit patient with me. Okay, let's do this one. So I have my turtle, and I think what I'll do is I'll draw a cross. So I'll go first, going in the forward direction. And then I think what I'll do is I'm just going to go back double the distance to take me all the way to the other side. So backward 200. And then to get myself back into the middle again, I'll just do another one of these forward commands, okay? And let's run our code here and double check our work. So now that I'm in the middle, what I can do is I can just turn in the upwards direction, okay? So I can do a TED dot left, 90 degrees. That will take me in the upwards direction. And then I'll just simply do that same type of thing, right? I'll go forward by 100. And then I can just go double the distance, right, in the other direction, in the backwards direction, okay? So I run my code, and you can see, goes out, goes back, comes back to the middle, goes up, and then it finishes in this downward position. So that's how I can complete that cross, okay? Now, is that the only way that you can solve this problem? No, that's not the only way that you can solve this problem. You may have written your code similar to me, and I see some students have written code that's actually different from what I did, right? Maybe what you did is you moved first to the left. Or maybe what you did is you first moved in the upwards direction, right? There's no right or wrong. Really what we're trying to do is we're trying to match the photo and stop and think about the types of commands that we might need to use in order to create this drawing. So oftentimes when we're writing code, there's no such thing as a right or wrong. Along the way, we will learn that when we're writing code, there might be code that's easier to read, or there might be code that's a little bit faster than other code, especially when we're working with algorithms. But in this case, there's not necessarily a right or wrong, as long as your drawing looks pretty good and similar, okay? All right, so when we were drawing our square, one of the things that you might notice is, number one, this is a lot of repetitive code, right? We're writing the same commands over and over again. However, one more detail that we want to think about is, let's say I said, all right, class, great job. You all did a great job drawing this square. Now I want you to draw a 17-sided polygon. How would you go about doing something like that? How would you do it, right? Well, probably you would go back to your code and you would say, all right, well, what I'm going to do is I'm going to, like do my forward command, and then I need to Do I need to do a turn command? Okay, in this case, the 17-sided polygon, I wouldn't turn 90 degrees. Actually, does anyone know how many degrees I would turn in a 17-sided polygon? Yeah, some students know. I'm curious. Brian?
All you have to do is 300. All you have to do is 360 divided the amount of sides of the shape.
Yeah, that's exactly right. Yeah. So I can do something like this. So I'll do that. And now I just need to make sure that I do these two things 17 times, right? That's 1, 2, 3, 4, 5, 6, 7, so on, so on, so on. I'm already losing track of what I'm doing, right? This is already making my life complicated. Look at all these lines of code, and all these lines of code do very, very similar stuff. And so, although I can use copy and paste, surely there's a better way, right? Even right now, I've lost track of how many of these I've done. I'm not quite sure. Well, I'm already starting to lose track of my drawing here. How much I've done. Is there a better way to do this? And a lot of you guys have your hands up, and I see that there's lots of people who have been asking me this question along the way. And the answer is yes. There is a better way to do this. And what I want you guys to already start to think about is when we're using computers, we're often using computers and our programs to do work that's kind of in a similar fashion to a calculator, right? Our calculator can do really, really complicated math very, very quickly, and also some repetitive or tedious calculations that would be difficult for a human to do. Not because we can't do them, because it's easy for us to lose track or make small mistakes. Same thing is true for our program. And what we can do instead is say, instead of repeating these same lines over and over again, what I want to do is just write one line of code that says, okay, Python, I want you to repeat these lines of code this many times, right? Because up until this point, what's happened is that in our code, simply our program started at the top, it imported our library so that we can use it. Then it goes to the next line, it creates a turtle. Then it goes to the next line, it executes this command. Do you guys see how it goes step by step by step by step and line by line by line? And really what we're doing when we create this loop, a loop is our ability within our code to sort of go backwards and redo some lines of our code over again. It allows us to save that logic in a small chunk of code and say, hey, Python, I want you to do this over again. So we can go back to our Thonny code here, and instead of, doing this code here with our 17, let's skip the square one. Let's see if we can recreate our 17-sided polygon here. So I would write something like this. I would say for I in range, here I have a 17-sided polygon, so I want to put 17 here. And then what are those commands that I'm trying to repeat over and over again? Well, I'm trying to do a forward command here. And let's do it smaller, because did you guys see on that first run it was going out of bounds? Let's do it smaller, like, I don't know, 10 or something like that. 10 should be good enough. Okay, and then let's do my right turn here. And like we said, for our polygon, we can just sort of take our 360, which is our full rotation, divide by the number of sides that we have, and that should help us out. So run our code here, and that looks pretty good. Actually, it's a little small. Let me make it a little bit larger for you guys to see. A little better like that. So this is a 17-sided polygon. Here's the thing is, when you get more and more sides of your polygon, it's hard, the angles become more extreme and it looks a little bit more and more like a circle. So this is pretty interesting to see. So maybe if we really want to create something that looks like a circle.
36.
Oh, 36? I can do 36, sure. Let's do 36 and let's make this a little smaller here because more sides, like 15 or something. Okay, and I think this is going to look pretty similar to a circle. Wow, that looks almost pretty smooth, right? So that's a pretty cool way that we technically don't even know how to draw a circle yet in Python Turtle. I'll save you the time and let you know there is a command in order to draw a circle. There's a circle command. But if we really needed to, we can just simply use this idea of drawing this polygon using our loop. So in this case, okay, I saved myself a couple lines of code. It wasn't so difficult in the case of drawing the square. But in the case of drawing this 17-sided polygon, oh yeah, this saved me a lot of lines of code and a lot of time. And this is a lot easier for me to read and to understand in this case, okay? So hopefully you guys are already seeing the benefit of creating these loops is that when we need to do really repetitive tasks, it allows us to simply write our commands in our lines of code that we want to repeat, and then just simply tell Python Turtle, hey, or tell Python, repeat these lines of code this many times. Okay, so that's kind of the idea of how this loop works. Okay, so like I said, because we only have an hour and a half long class, we are limited in the amount of time that we have to cover a specific command. So there is so much that I would love to teach you today, but I just don't have the time to. Like I said, drawing circles, I guess technically we drew a circle today, but there's a circle command and some other commands that we can use for some non-trivial shapes. We can change the turtle speed, we can change the screen color, we can pick up and put down our pen. We can do commands to use the coordinate system to go to specific positions. We can do things like clear the screen when we want to. We can do things like fill shapes with colors. We can do animations. We can do like input from the user to say, okay, when you click on the screen, I want you to draw from here. Or when you type this key on the keyboard, I want this action to happen. I want my turtle to move forward 100 or something like that. These are all things that we learn in the 100 level Python class, but we just don't have the time to learn today. So there's so much more that we can do, and we can do drawings, we can do animations, we can create games and all that kind of stuff, just using these commands that we can learn in Python Turtle. And along the way, as we learn all these different commands and create all these drawings, we get to learn the fundamental pieces of programming, like loops and conditional statements and functions and all that kind of stuff that comes along the way.
Computer science
Okay.
and artificial intelligence are tools that will change the future.
Oh,
XCamp Academy is a community dedicated to inspiring and cultivating the next generation of computer
sorry about that. I don't know how I hit play on the video without even noticing it. Okay, let me try again. Let me share my screen. Okay, try again. All right, so like I said, there's so much more that we can learn, and we learn in the 100 level class. Like I said, we don't have the time to learn today, but there are a few other things that I want to show you guys to sort of give you an idea, because XCamp and programming in general, it goes way beyond this whole Python Turtle and doing drawings. And so the question is, what else can you do with programming, and what are the types of things that you would learn in XCamp class? Well, it goes way beyond that, and we can learn things like algorithms. And so algorithms, they're essentially just this idea of like giving a step-by-step recipe on how to create to solve a specific problem. So let me show you, if you're not too familiar with algorithms, I want to show you an example here of a puzzle and how we could sort of solve this puzzle using algorithms. Okay, so look at this photo here in the bottom here. So it's this puzzle. I'm not sure if you guys seen stuff like that, but usually it's in like this little drawing book where you have this maze, and you have to sort of maybe take your pencil and draw a path and see if you can get from the start to the end. Okay, so that's kind of the idea of how this maze works. And so, if you're thinking about doing this by hand, you would sort of take your pencil, you'd start at the little character, and you sort of move around the screen in order to take your character and put them in the right direction. Please don't annotate the screen and show. I know exactly how it needs to move in order to get to the end. But the question is, if you had a puzzle like this and you needed to use some computing in order to figure out how to get from the start to the end, well, how would you do that? If we needed to find either that a path exists, or maybe we want to find what is the shortest path, or what is the longest path, or how many paths get us from the start to the end. Okay. In this simple example, it's easy to sort of look at how it is and find the answer. In a more complicated example, that would be more difficult to do. Okay, so that would be more difficult to do. We can use algorithms to solve this problem. Okay, so we can use algorithms like depth first serve, breadth first search in order to figure out these different paths from a starting point to an ending point. Okay, now here's another example of an algorithm. This is, let's say, for example, we were playing this game and I said, I'm going to think a number in my head between 1 and 100, and I want you to guess what that number is with as few tries as possible. And the way that this game works is when you guess the number, I'm going to tell you if the number that I'm thinking in my head is higher or lower, and that way you kind of know which direction to go in. Well, how would you do something like that? Well, of course, you could start from 1 and guess, hey, Teacher Brendan is your number 1, 2, 3, and keep doing that. But if your objective is to guess as few times as possible, probably what you want to do is guess right in the middle, and then I'll tell you higher or lower. And then along the way, once I tell you higher or lower, you've immediately eliminated half of that search space to then narrow down even more and more, right? So this idea of sort of taking the middle point and sort of saying, hey, it's bigger or smaller than this, and then going to search again in that direction is actually something called a binary search. A binary search has lots and lots of application beyond this little game that I've showed you. And it's a very, very powerful algorithm that we can use in order to speed up this searching process when we're searching and in an organized search space, when there's order to the items that we are looking for. Okay, so that's a little bit about algorithms. Let's talk a little bit about data structures. And so, we didn't talk about too much about this data that we're storing, but we have some like text information or some numbers or stuff like that that we want to hold in our programs. And so the question is, when we have that information, well, what do we do with it? Where do we put it to organize it and, keep track of all that information, make sure it's, how we need it to be? And that's where data structures comes into play. So for example, in this photo here, it looks like in this photo, there's, a bunch of people that are lined up at this little kiosk for this store in line to order themselves a boba tea, right? And so how does this work in real life? Well, if you want to get a boba tea, you would say, all right, there's a line. I'm going to put myself at the end of the line. And then, as the people who are at the front sort of punch in their orders or at the screen, or maybe they say to the worker there, their order, the worker will take their order and they'll send it off to the kitchen for it to be made. And you'll wait your turn, and when your drink is ready, then you'll go and pick it up. And the way in which that this is organized is in this sort of line structure, right? Where the people who are at the front of the line get served first, and the people at the end of the line, they have to wait their turn in order to move up to the front of the line, okay? And so we actually have a data structure, a way of organizing our data within our computer programs to help and represent this type of structure. And this is called a queue, okay? A queue is just another name for a line, okay? So it has that same idea where the people at the front get served first. And once they're done, they get their ticket and they leave from the line, and then everyone gets to shift upwards, okay? Everyone shifts upwards. And then, so if you want to enter line, you have to go to the end and you have to be patient and you have to wait your turn, okay? Now, there's other data structures as well. Okay, so here's another one, and this one is called a stack. All right, and this one is more represented. You can think about it more in terms of like a book, where if you want to add a book to your pile of books, you put it all the way at the top of the stack or the front of the stack. And if you want to grab a book that's not at the top of the stack, what you do is you have to take off the ones from the top first, and then you get the book that you want, and then you can put the other ones back. Okay, so this is another way in which we can represent some data, and in a structure that we call a stack. Okay. Oh, and so the last point that I want to say is that you might be looking at these data structures and saying, okay, cool, yeah, it represents people in a line for some boba tea, and this one represents how we can store some books in a pile. But what do these really have to do with anything else? Well, one thing that you get to learn along the way in XCamp is that actually these data structures, this stack and this queue, are ways in which we can store our data in order to solve this problem of finding path from the start to the end. Okay, so how do we use those structures in order to solve this problem of doing this path from the start to the end? That's something that we will learn along the way. That's not something that we have for today. Yeah, that's something to sort of make you stop and think about, well, how could I, put this information in this data structure in order to help me solve this problem from getting to the start to the finish in a different way. Okay, that's something for another day. All right, so at the end of the slides, there's these homework problems that you can give a try to. So this is not mandatory, but in our XCamp class, we would have some homework problems that we can do. Okay, please stop annotating on the screen. So in this example here, all you'd have to do is you'd have to draw this star shape. So it has some forward commands involved and it has some turning commands. You really just have to find out what's the angle in which you want to turn. And then also you have to change the pen color to red and the turtle shape to the turtle. Okay, so you can do that one there. As well, there's this shape that you can use the power of loops in order to draw these squares. Okay, so this one looks a little bit more abstract and is probably a little bit more challenging, but if you got a good hang of how we can do those loops, then you can use the different pen colors and sort of use the loop in order to draw all of these squares in a pattern like this. Okay, so if you're looking at this and kind of confused, the idea is simply that you're rotating some amount, which I won't tell you, and you draw a square, and then you rotate again, and you draw another square. Okay, and then you can do that in a loop to create cool patterns like this. All right, so yeah, that concludes. There's also some multiple choice questions, but that concludes our lesson for today. And I hope this gives you a little bit of a taste in what XCamp class is like. Yes, I did the majority of the talking today in XCamp class. Usually you guys would do a lot of talking too, and I'd always answer your questions, but thank you for being very patient with me. I know it's difficult on the very first class and with a lot of students, but hopefully you enjoyed the lesson and you got a little sample of what XCamp class is like. Okay. All right, so I'm gonna stop sharing my screen. And like I said, the next thing that we're going to do is we're going to have some time for, I'm going to turn it over to Joyce. And what we're going to do is we're going to allow your parents to ask some questions, or she's going to talk a little bit about XCamp. And after, she'll answer some questions about registration and classes and all that kind of stuff that you might want to know. Okay. All right, so thank you guys for being a good class, and I hope you enjoyed, and I hope that I see you in an XCamp class sometime soon. Okay. Joyce, are you here?
Okay, hi. Hi, I'm Joyce. I'm in charge of the new student admissions at XCamp. Okay, if you have any, thank you all for joining the trial class. So if you have any questions, so you can ask me and I can explain to you. Both Chinese and English are welcomed. So, okay, first I will show you our learning path of the XCamp to you. Okay, here is the learning path of XCamp. So the trial class you have learned just a moment ago is about our 101 word class. And in beginning level, you will learn 3 classes, 100 to 102 class. You will learn Python language. And after you finish beginning level, you will join the intermediate level. So from 200 class, you will transfer C++ language. And after you finish 202 class, you can attend the user core competition, bronze level. And after finish 300 class, you can attend the user core silver class. Okay, and in the 6, so can you see the 602 class? That class is for the students who want to pass gold, join to platinum division. And after you are already in platinum division, you can join 603 class. And then this class is for students to prepare for join the national camp. Okay, so there are about 25 students can join the national camp. So this year, 12 students in X camp have joined the national camp. Okay, this is our learning path of the competition. But if you don't want to take the user core competition, we have another roadmap. So we have several classes you can take. After you finish 1-2 class, we have game development class. If you are interested in game design, or you want to make your own game, okay, you can join the game development class. And we also have AI class. So after you finish 202 class, you can join AI class to learn some AI knowledge and make some project. And you can do research based on your AI knowledge. We also have APCS class. So this class, APCS A class, this class is you will take, maybe you will take in your high school. So that is AP. There are 2 AP classes about the programming. One is APCS principle, and then the other is APCS A. And yeah, if you want to take APCS A class out of your school, you can join our class at XCamp. Okay, this is our 2 learning roadmap. Okay, so do you have any questions about our learning map? Okay, if you have any questions, you can unmute yourself and ask me.
嗯，老师，我有一个问题，
你说。
就是我因为今天的试课是那个老师说他是注重于那个100的课程，CS 100的课程，他主要是用那个 Turtle 的 library。那101跟102各会 focus 在哪个 library 呢？
我们的100和我们是这样的，100和101呢，它呢是其实它是没有课程的一个递进的关系的，就是说都是给零基础的孩子提供的。但是如果你的数学程度比较好的话，那你可以直接从101开始。我们有一个数学的测试，可以联系我做一下数学的测试。那100呢，是我们用 Turtle 来教画图，但101呢，就是比较 serious 的一个文本的编程开始，然后他们其实可以已经开始涉及到算法。到了102的话呢，其实我们就是主要开始学算法了。那刚才那个 Brandon 老师也讲了，我们其实我们的这个 programming 课呢，它重点不是说是教 语言，我们课程的重点是算法和数据结构。所以我们开始是让孩子用 Python 来入门，然后到了 intermediate level 的时候就转到了 C++。然后这样的话，因为我们是比较建议学生用 C++ 呢去参加这个 USCO 的比赛，因为80%左右的考生都是用 C++ 去参加这个比赛的，因为 C++ 的速度相对来说比较快一点。但是为什么我们不从 C++ 直接入手来学呢？因为对于这个低年级的孩子来说，尤其是很多孩子都是5、6年级的孩子，从基础班开始学 C++ 这个语言，对他们来说呢会比较有点难度，而且呢没有 Python 那么的有趣，所以我们一开始还是以抓住孩子的兴趣点入手，来让他们开始接触编程。
好的，明白了，谢谢老师。那我想问一下，就是200的课程，您之前的那个 slides 上面写着有 placement test，它是会考一些什么东西呢？会考一些 C++ 的基本的指令的 syntax 之类，孩子能知道吗？还是说它是用Python 来考试，看你就是对这个algorithm 啊之类的理解到了什么？
对，是这样的，我们的测试呢是不测语言的，你可以用任意的语言来做。我可以给你们看一下我们这个测试的这个样子啊，是什么样子的。就是你在测试的时候呢，你是可以选择任意的语言去做。但是呢，如果你要想做编程测试的话呢，是你需要有一定的编程的基础的。你看，这是我们的测试网页，你们进到我们的官网的上方，给你们看一下我们的官网啊，对。就在这个地方，就是这儿 assessment，你们可以自己点进来，然后呢注册一下啊，注册，因为我已经 log in 了，所以这个没有注册。你们注册的时候呢，一定要选的身份是学生，如果选家长的话，你们是没办法做测试的啊。那你们进来以后呢，我们其实是有好几个测试的，我现在已经在编程测试里面，你们看这边就可以选语言。你们可以用任意的语言去做，你熟悉的语言去做。我们呢测试呢是他们的这个 programming 的能力，不是测他的语言的能力。所以你不用担心，就是用什么语言去做，你孩子会什么语言，你就用什么语言去做。但是有一个问题是什么呢？就是如果他只会 C++，比如说我们现在在这个里面，对吧？你看我们这个路径图回来。如果他只会 C++，但是他测试的结果是只能上102班的话，那可能需要他提前把 Python 的 syntax 呢自己学一下，不然的话呢，我们这个课是用 Python 教的。但其实以我目前了解的，我这边经手了几千个学生了，这种情况其实是比较少的。比较多的学生是什么呢？就是他们呢在200以上的班，但是他们不会 C++。如果他测试的结果是上200班的话，那很好。这个200班我们老师会教 C++，但如果他是201以上又不会 C++ 的话呢，那他需要自己把语言转到 C++。我们这边也会提供，就是一个转语言的视频教材。教材的视频的时间大概是2到3个小时，然后有配套10周的作业。这个是一个付费的教材，内部学生是100块钱。那我们很多学生都是这样转的。
好的，谢谢了。
所以你们如果需要做测试的话，你们自己到官网上去点那个 assessment 的去做一下，或者你联系我，我来发给你们一些测试的 instruction。
老师，我问一下关于那个测试啊，不好意思，插个队，很快的测试问题。
没事，你说。
如果那个孩子他以前没有编程的基础的话，其实是不需要做测试的，是吧？
对，没有编程基础的话呢，你们不需要做编程的测试。但是呢，如果你是7年级以下的，上面有一个数学的测试，希望你们做一下。数学测试呢是判断你是上100还是上101。我们数学测试题一共是16题，如果你是8到11分以上，我们是建议上100。如果你是12分以上的话呢，那我们建议上101。 但是你如果低于8分的话呢，那我们是建议可能到时候我们可以再商量一下，就是如果看看他平时的数学成绩，因为有一些孩子他可能数学的概念他是知道的，但是呢，他那个数学的题呢，他可能以前没怎么接触过，所以可能一下子没有做好。这个到时候你们最好就是加我一下，我看一下啊，扫一下我的这个二维码，对，这个 OK，我看这个中间这个啊，这个是我的，这个中间这个是我的这个微信号，你们可以加我一下，然后到时候我根据孩子的这个实际的测试情况，以及他本身现在的年龄，以及他具备的一些编程的和数学的基础，我会给你们商量出一个比较合适他的一个课程的路径来。OK，好吧。另外，我们今天还有一个 promotion，就是如果你在体验课当天，就是今天报名的话呢，我们还会有额外的50块钱的优惠。那我们现在的话是5月18号之前啊，5月18号之前是一个早鸟的优惠。但是如果你们只是报100和101班的话呢，是这个早鸟优惠对你们来说是没有什么作用的，因为100和101班我们现在是周年庆的优惠，已经优惠了100块了，所以100班的学费是680，101班的学费呢是780。但是你如果2个班一起报，就是你夏季和秋季同时注册的话，那我们会有额外50的优惠。那当然，你如果今天报名的话，还再会有50块钱的优惠。所以这个是今天额外的一个 promotion 啊。但是你如果是报102以上班的话啊，如果你今天是报102以上班的话，那你这个早鸟优惠就可以用上了。早鸟优惠是每个班是50块钱的优惠，所以你102加200同时报的话呢，是一共有150块钱的优惠的。所以这个具体的这个优惠的话，你们也可以添加我，然后来跟我了解，好吧？也可以加到我们的这个 WeChat group 里面来。好，这上面都是我们的联系方式。这个电话，这也是我的电话，你们也可以打这个电话直接找到我。看看大家还有
101什么780的是线上还是线下？
对，线上，我刚才说的都是线上的。那我们现在在湾区、西雅图、洛杉矶、纽约、波士顿都有开设线下班，但线下班呢，只有100和101，就是其他地方的，除了湾区的。湾区的线下班呢，目前呢就是有201还有几个名额，因为这个都是以前的线下班的学生升上来的，空出来的几个名额。对，所以有关线下班的话呢，如果你们想了解线下班，也欢迎添加我来咨询，因为每个线下班的这个形式都是不一样的。有一些线下班它的时间也是不一样的。还有另外就是我们如果在湾区的小朋友，我们还有个 summer camp，summer camp 是7月21号到8月1号是全天的 camp，是早上9点到5点，在 Cupertino 的一个叫 Metis School。如果你们那个时间段有时间的话，欢迎让孩子来参加这个 summer camp。这个 summer camp 是效果非常好，而且孩子们学的也非常开心。我们这个 camp 已经办了好多年了。这个 summer camp 的详细的情况也欢迎添加我来了解，好吗？
camp 上完是不是直接可以上102了？
是我们 camp 是这样的，我们 camp 有100到1023个班。如果你第一周上101的话，第二周可以紧接着上102。这样的话，你秋季就可以跟上200。但这个呢，我是建议稍微年龄大一点的孩子这样上。如果你们只有5、6年级的话，我不太建议这样上啊，因为这样的话孩子学的太紧密了，而且你们不用那么赶。因为我们的这个课程哈，说实在的，尤其从200开始就不太容易了。就以我们往年的经验来看啊，如果你比如说5年级你就开始了，对吧？那我们1年半，其实1年半的时间就可以把这6门课都上完了。我们1年4期，很快的。那你相当于你如果开学是100班，对，从100开始上，但是其实你还在5年级，你都得上到202了。但实际上可能他这个时候呢，他会有点跟不上，就是学编程不用那么着急了，就是你就让他这样慢慢一级一级的往上上，比较这样上的比较那个。但是如果你年纪比较高了，比如说你7、8年级对吧，或者8、9年级，比如说我想就是冲一冲竞赛的话，那你其实来我们的 camp 是非常合适的。 当然，你这个像如果是你来 camp 上一期哈，比如说你只上100或者101，这样的话其实也是 OK 的。到时候可以看孩子学习的情况，因为有的孩子他可能学得非常好，他也很感兴趣，他要继续往后报，那你就根据孩子的这个意愿来给他继续往后报就可以了。反正我们这个是我们1年的4期呢，是每一期每一个 quarter 都有100到603班都有的。所以你任何时候报都会有合适的班级去让你去参加的，好。
这个 meeting 的 recording 怎么 access？
你需要这个 meeting 的 recording 吗？那你可以让你的家长来跟我们要一下，跟我们的工作人员要一下，因为我们这个 recording 应该不会发给大家，就是不会发给，就是通过邮件发给大家。如果你们有需要这个 recording 的话，可以就是添加我们的加我吧，加我都行。然后或者你们应该有的之前已经加过我们的工作人员了，跟他们要，好吧？这个我估计可能要等一会儿，等他这个 Zoom 它 loading 了以后再给到你们。好像是这个是有人举手，还是说一直刚才上课发言一直举在这儿的 ？Brian 是有问题吗？还有 Iris。
哎，你好。
哎，你好，哎，Iris 你好，
我这个朋友妈妈推荐的，她的孩子 Summer 在上这个，她强力推荐。
谢谢，
他是说他的 uncle 的 colleague 是这个CEO Create School，那我们是第一次，我们以前疫情的时候去其他的软件上上过 coding，我现在问小孩子的进度，就是要安排报个什么样的班级，我刚才都不在哦，我是刚刚过来，所以我不知道你之前讲了什么，然后我也不想让你再重复，现在因为很晚了嘛。
那你这样，你加我的微信好吗？你可以扫我这个，扫中间这个 WeChat Assistant 的这个是我。
好。
然后对，然后你到时候我再跟你，我看一下这是不是我？
对，
这个是我官方助手，对。
因为刚开始我们今天之前都没有收到任何那个你们那边的消息，我都不知道怎么上课，所以只要应该 OK 扫一扫。
刚才他上了吗？孩子上了吗？
上了。
那你待会儿问他，你问他上的感觉怎么样？然后你加我的话，我再告诉你一些我们这边的详细的 information 给你。
对，我看一下这个 summer 我们怎么安排，是怎么上法那些咨询一下怎么安排课程。
没问题。这是我的电话，你也可以把我电话记下来。
等我一下。
电话也行，对，因为打电话可能说的更快一点。
对。那我等一下下线了，可以给你打个这个电话。
可以呀，你可以。
好，那我就不打扰你们了哈。
行，好。
那我等一下晚一点给你打，10分钟以后。好，谢谢你。
行，没问题。好，拜拜。
老师，我这里还有几个问题啊，一个 comment 加几个问题。一个 comment 是这样的，我的一个高中同学，他在谷歌是做了 software engineering 做了好久了，然后他的儿子刚刚今年考大学，然后呢，他跟我说 Xcamp 帮助了他的孩子从coding 什么都不懂的，然后现在去考入一个还不错的学校的 computer science 的 degree。然后他跟我们说就可以放手交给 Xcamp 就可以了。
这么高的评价，他叫什么名字啊？你可以给我吗？
我到时候可以给你。
好吧，我们这边其实有很多孩子的案例，我可以分享给大家，就是各种各样的，你们肯定能找到跟自己孩子差不多的。
是。然后其实我有两个问题，第一个是因为现在报 summer 的准备 summer 的时间，其实对我们来说怎么说，应该有点晚，我们很多都已经安排好了，很多事情。然后呢，但是我知道你有夏季班有秋季班，但像这种夏季班秋季班的话，如果我们 miss 掉几个礼拜的，比如说礼拜六礼拜天的这种课程，这个会有很大的影响吧？这是第一个问题。第二个问题不把我忘记，第二个问题是最小的年纪一般是几岁可以上？
我回答你第一个问题啊，就是如果你要 miss 掉好几节课的话，那我是建议你干脆暑假就不要开始，你从秋季开始。但是呢，你如果只 miss 掉1、2次课的话呢，我们其实跟其他机构有一个最大的区别是什么？我们的这个课后的辅导系统是非常非常强大的，应该没有哪家机构可以做到我们这一点。首先，我们每天晚上5到8点美西时间都有 homework night。然后小朋友们可以到 Zoom 里面来做功课，我们有老师在线的答疑。然后另外就是基础班的有额外的 TA Office hour，其实我们还有一些 volunteer 的学生可以安排他们1对1的去辅导。然后另外我们还有 Discourse 平台，如果他们有不懂的问题，可以发在 Discourse 平台上，我们老师是24小时在线的，因为我们国内还有一个教师团队。然后另外的话就是每一节课都会有录像，如果你 miss 掉课呢，我们是会就是你就看那个录像的回放。但是呢，可能有人会问，如果我报的是礼拜6的课，但是我这周我礼拜6不能上，我能不能去上礼拜天的课？答案是不好意思，不能，因为我们每个老师的这个课程的进度呢有可能不一样，而且我们每个班的人数是固定的，就是为了便于管理以及为了孩子的学习效果，我们会提供录像给孩子，然后也提供这个课外的辅导给孩子，但是呢，你是不能去加入到另外一个班的，所以这个是这样子的。然后那个每一周的话，就是反正我们每一年4期的话，都是有从基础班一直到最高班的。所以你如果之前，比如说暑假你们很多人都要出去玩，缺课太多的话，那你就从秋季是9月7号开始，你就从那个时候秋季开始上，那个时候基本上大家都回来上学了，可能就缺课的话就不会太多了。那如果是线下班的话呢？线下班如果缺课怎么办呢？线下班缺课的话呢，我们就会给他提供，也是给他提供线上班的录像去给他看。但是呢，这个呢，线下班的小朋友呢，就是要报名的时候要尽量的谨慎一点，因为尽量就不要缺课，因为你线下班跟线上班呢，就是毕竟他就是他不是他自己本班老师的课程呢，所以会有一些，就像我刚才说的进度上面的问题，所以他去看录像的话呢，可能效果就不如这个他直接在课堂上上课的效果好。好。然后第二个问题是，哎呀，第二个问题是什么？
最小，因为我
最小，对对对
对
对，我们是建议5年级以上的孩子开始学。当然了，有一些4年级的孩子，比如说现在4年级开学就5年级的，对吧？那因为我知道，我们华人孩子的数学都是很强的，尤其是我这几年的这个工作的经验下来，孩子们的数学是1年比1年厉害。我们以前是收6年级以上的学生，5年级都不收的，现在5年级也开始收了。然后4年级的孩子就是说，我们不是按照年龄来一刀切的，就是有一些孩子呢，他其实家里面开始的比较早，他其实都已经会编程了。也就是说，如果会编程的孩子，他如果做我们的编程的测试，到哪个班就到哪个班。他即便只有3年级，我们可能也会收的啊，可能也会收的，因为这个孩子可能是个好苗子。但至于他后面能走多远，那我们得走一步看一步了啊。但是呢，如果他没有编程基础的话呢，那我们需要看一下他的数学基础。像4年级的孩子呢，那数学至少你要达到8分以上。我们可以来上我们的100班。但是有一些孩子，如果他像4年级，他已经数学他很好，对吧？我知道有一些孩子可能3、4年级 AMC 8都拿到了，所以那他可能数学会达到我们101班的程度，但其实我们也不太建议他从101开始上，还是从100开始上，就是慢慢的把基础打扎实，因为其实你也不在乎就是快这个3个月嘛，对吧？所以这个是我们这个上课的这么一个节奏。当然我们孩子的话其实是会根据他每个孩子不同的情况，像我们今年有一个进国家队的孩子，他其实就是他开始进来的时候测试是只到200班，但是后来他上了2次以后呢，他觉得太简单了，那其实那他跟我们提出来以后，我们其实会给他一个重新的测试，然后到时候会根据他的情况，他其实在我们这边的话，因为他学的非常的快了，然后他后来就是也是有的时候比如说我们会建议他一个时期同时上2门课，比如说202以上的班的话，同时上2门课，所以他其实后来就是从200一下子很快的就到了大概603班，然后今年进了 camp， 好像今年是不是应该申请大学啊？好像录取的也都不错。 我们603班的孩子啊，基本上是全部进的 camp，然后是90%的孩子是进的 MIT，所以这个的话，你如果能够被教练挑中进603的话，那基本上其实是算是半条腿进 MIT 了，应该可以这样讲。好的，行 ，OK。
老师，我还有个问题啊，如果我们上线下班的话，当然你提到就是线下班的1个礼拜1次课，然后呢还有作业，一般我们要规划孩子的时间的时候，1个礼拜要
时间是吧？对，
多少时间？几个小时？
基础班的学生啊，除了1周2个小时上课以外呢，然后他们的作业大概是1到2个小时，depends 孩子的程度，学习的程度。但是其实绝大多数孩子应该1个小时就能做好了。然后在网上的班 ，intermediate 班以上呢，那他们的作业呢可能要难度加大，那估计可能要2到4个小时。但是我们对孩子的建议呢是，如果一道题你20分钟都想不出来的话，就不要做了，因为编程跟英文啊、数学其实不太一样的，就是你要知道怎么样去寻求帮助，然后那这个情况，我们的这个课外辅导系统就起了作用了啊，那你就来找老师，然后呢，老师会给你一些提示，或者我们的课程网站上也会有一些 hints，然后你可以去通过老师的提示，或者你去看一些之前的录像或怎么样，你再想一想，然后再把这个题目做出来，就不要死盯着一道题死求。差不多的话，所以我们每周大概差不多3到5道题的作业吧，另外还有一些 bonus 的作业，就是看你的程度完成。另外我们其实还有每年的暑假和寒假，我们会有100题的挑战。每年赛季9月份到1月份的时候，我们还会有赛季的模考，然后冬令营、夏令营这些，就是我们会有很多的就帮助孩子们去参加竞赛的这么一个训练。因为你除了上这个周末学知识点的课程以外啊，那你其实必要的训练还是需要的，所以我们这些其实都会有，就只要孩子有兴趣有时间，他愿意做，那我们这边的资源和师资力量肯定是都能跟得上的。因为现在全美来说，能够有 Gold 以上，尤其是 Platinum 级别的这个训练的机构的话，应该是可以说是没有的。Xcamp 是唯一的一家啊，所以我们这边其实有不少从 Alpha Star 过来的小孩，Alpha Star 过来的小孩，他们其实很多都是到了高 level 的话，那边的老师可能就有点，他们觉得可能需要反正就换到我们这边来了啊，换到我们这边来，然后其实很多人会觉得，如果一开始就从我们这边上的话，效果会更好一点，因为它更系统嘛，教练对你的了解会更深。但我们这个602班啊，你看我们这个 advanced level，尤其是400以上啊，大家看这个就是说，这个应该是以前老的表了。我应该给你们看一个新的表，就是它到了一定的 level 以后呢，你上面的课呢其实是不需要全部都上完的，因为我们的教练呢会从这个地方来挑人。对，这个是我们最新的表了，给你们看一下啊。这个对，像到了这个 advanced level 的话，到这边的话，602的教练会到下面来挑人。那你被挑进去以后，当然这边都已经是过了 silver 的学生了。那到了这个班以后呢，就是去冲那个铂金班了。然后603的教练是从602的里面来挑人的哦。所以这个到上面的话，基本上就是不是说是你想进就进的，是教练同意你进才能进的。好 ，OK， 看看大家还有没有其他的问题。这个的话，我再把我的这个微信号跟大家 share 一下啊。然后我们还有就是YouTube 的频道，你们搜那个 Xcamp 都能收到，然后 Xcamp 的官网都可以，然后官网上也可以跟我们约1对1的咨询，都可以的啊。好，那如果没有问题的话，我们今天的课就到这儿结束。OK， 好，行，欢迎大家的参加。